Get ready for the Module 4 tests. Here we're going to be covering the review guide. So there are definitely some curveballs on this review guide I really want to discuss. So make sure you watch kind of the whole video. Or there might be questions that you think you knew, but there might have been a small little thing you could not have realized. So make sure you check your answers on any of these problems. Okay, so we're going to start with number 1. Write a recursive rule for the sequence. Now, it doesn't give us a sequence. Okay, what it gives us is a function. Now, there's kind of more than one approach to this, but what I would say is maybe plug in numbers, because neither of these numbers is the first term, and it could be misleading as such. It could make you think like it is as such, but it's not. So what I recommend is sort of maybe plugging in numbers to complete this sequence and then write the recursive rule like we know how. So let's write out the actual sequence. Now to do that, right, because this one right here is an explicit function, if I want to know what the first term is, then I'm just going to plug 1 in. So when I plug 1 in, this would be -2 plus 6 times 1, which ultimately means that the first term would be a -2 plus 6, which is 4. So the first term is 4. That's going to be useful for our recursive rule. We're going to need to know that. Let me pull up the test actually real quick. Not actually on the screen, but on paper. Yeah, okay, I just want to make sure. Okay, and then let's continue to find like the second term. The second term will be -2 plus 6 times 2. 6 times 2 makes 12. -2 plus 12 is going to be 10. Let's try and find the third term. The third term would be 6 times 3, which would be 18. -2 plus 18 is 16. I don't know why I'm writing plus signs, but anyway, second term was 10, third term is 16. And now, because it's an arithmetic sequence, you'll notice that we are going up by 6 every time. And that is due in part because you're doing 6 times n, right? So every time you add another n to it, you're going up by an additional 6. So the 6 really is kind of the common difference. You might have known it from looking at it here, but it was nice to verify through writing the sequence out. Writing the sequence out, we verified, the common difference was 6. So now we have enough information really to create our recursive rule. So the recursive rule would state first f of 1 equals 4. That's just saying that the first term is 4. And then our function would be f of n equals f of n minus 1 plus 6. So this recursive rule, what it's stating is that this right here, remember, this is our box. This states that the previous term plus 6, and that's exactly what's going on here. Because we're just taking our previous term, we're adding 6 to it. So even on the test, you're going to be asked pretty much to use this formula. It's always going to start with f of n equals f of n minus 1. That's just part of the formula. And then plus 6 just because of our common difference. So you're going to look for something like this on the test as well. So if your common difference was -4, it'd be the exact same formula, but it would be -4 at the end. If the common difference was adding 10, again, it'd be the exact same formula, just with the plus 10 at the end. So get used to seeing this formula. This one is going to be plus 6 because, of course, our common difference was 6. Okay, and of course, make sure you understand the first term is very useful as well. This will be multiple choice, so you might see the same equation on multiple answer choices, but the answer choices might have different first terms. So make sure you understand, plugging in the value of 1 to identify what the first term is, because the first term was not -2, and some people might have thought it was. All right, number 2, find the 16th term in the following arithmetic sequence. So in order to do that, what we're going to do is write an explicit rule for this. It doesn't say write an explicit rule, but we kind of need to in order to find the 16th term. The other option is just to go out and do this all the way up to 16. So when in doubt, you can always just kind of continue the pattern until you get to the 16th number. But a faster way would be to write the rule. So the explicit rule is f of n equals f of 1 plus d n minus 1. Hopefully you've memorized this formula by now. And now all we're going to do is just plug in f of 1 and d, our common difference. So to complete this formula, our first term is -6. So that's going to go there. And then our common difference, you have to be really, really careful with these negatives, is actually going to be -7. You're actually subtracting 7 because every time you get more and more negative, you're subtracting. So -7, -7, -7, -7. So be very mindful of that if you have negatives on the test tomorrow. And so now you've got your rule that you can use. So if you want to find the 16th term, you're just going to plug 16 in for n. So our function f of 16 will equal -6 minus 7 times 16 minus 1. So essentially, if you're going to work this out, let me rewrite that. There we go. If we're going to work this out, just do 16. Obviously, 16 minus 1 is 15. So if we did 7 times, oops, hold on, menu, here we go. 7 times 16, and then we did, okay, so that's 112. So it's going to be -6 minus 112, which is equal to -118. Equals -118. All right. So, yeah, definitely the key number 2 here is remembering this explicit formula. Again, this is multiple choice on the test, but what good is multiple choice if you don't know how to do the problem? All right, so number 3, find the first 5 terms of the sequence. Now we have the recursive rule right here because we know it's recursive because it's got f of 1. It tells us what the first term is. The first term is 6. And then it tells us the rule with f of n minus 1, which we'll talk about there in a second. So our first 5 terms. Well, we already know that the first term is 6. Gives us that information. So let's find the next 4. Now, in order to do that, remember to keep in mind of where the f of n minus 1 is and cut this all out, right? In that place, right, put the space. So it's going to be 2 times blank, which means 2 times our previous term. So this is where we're going to plug in our numbers, right? So the first number we're going to plug in is 6 because 6 was the first term. So we're going to plug 6 in, and this is going to lead to the answer being 12. 12 being the second term. 2 times 6 makes 12. And then we repeat that by plugging 12 in and multiplying it out. 2 times 12 is 24. So 24 is our third term. Then we plug 24 in because that was the answer we just got. And we find the next term, which would be 48. And then lastly, we plug the 48 in order to get the next term. 2 times 48 is 96. So our first 5 terms are 6, 12, 24, 48, 96. But obviously, remember the key to this problem is find the f of n minus 1 and take it out, put a little space there, right? So rewrite the formula as 2 times blank rather than 2 times f of n minus 1. Because that can really alleviate some problems. Just keep in mind, you're never using this minus 1. You're never actually subtracting anything. You're never really plugging anything in for n or f. You're just using this entire thing to sort of place where the previous term goes. Okay, that's all that entire thing means. Doesn't mean subtract 1. Doesn't mean do anything of that nature. It just means use the previous term in that spot. Okay. So number 4, find a function that describes the arithmetic sequence 16, 17, 18, 19, etc. So let me look at this one on the actual test real quick. Okay. Now, a heads up, on the review, this is going to be a little different than your answers on the test. So, oh wait, am I looking at the right one? Yeah. Use Y to identify each term in the sequence and n. It's not asking really for an explicit rule or a recursive rule. Funny enough. Let me see. 1 second. It's pretty obvious, really, on the test what the answer is. For one particular reason, but I'll kind of give you a hint. So, if you were to write, the explicit rule for this, it would be f of n equals f of 1 plus d times n minus 1. But so when we plug it in, f of 1 is 16 plus the common difference. Common difference is 1, and then times n minus 1. I'm going to tell you now, this is a correct function. F of n equals 16 plus 1 times n minus 1. However, it's not written that way on the answer choices on the test. So if you want to write it like the answer choices, one thing you could do is just kind of use the answer choices, plug in values of 1, 2, 3, and see what lines up with these numbers. Or we could just rearrange this. So let me rearrange this. I'm going to pull it over here onto the side and kind of show you what I mean. So we have 16 plus 1 times n minus 1. Well, if we distribute this 1, again, we don't normally do this, but we're doing this because it's not written in this format on the test, just a heads up. So, but if you want to just rearrange it, kind of simplify this, you can distribute R1, which should be 16 plus 1n minus 1, which is essentially just 15 plus n. So that's a perfect rule for our function, 15 plus n or n plus 15. So see what I did there, right? I mean, I just kind of simplified what we normally had, the explicit rule, into this. So this is kind of how it would look on the test. So you're gonna notice on the test there's not any answer choices that look like the explicit or recursive rule. No answer choice that look like that. However, there is an answer choice that is the same thing as this. It's just up to you to kind of simplify it down into that answer choice, right? So the answer here would be f of n equals n plus 15. All right. Okay, let's look at number 5. Number 5, write a rule for the nth term of the sequence. Use your rule to find the 100th term. All right, so this is getting pretty straightforward. Just make an explicit rule that would work out really, really well. So an explicit rule, f of n equals f of 1 plus d times n minus 1. All right, so let's plug everything in. So f of n equals, f of 1 is going to be our first term, which is -8 in our sequence, plus d. Now, it's going to take a little bit of work to kind of figure this one out. You might be better off taking numbers and subtracting them. So, for example, 26 minus 9, right? Try to find the difference between two numbers. Any two numbers would be fine. 26 minus 9 is 17. If you want to verify that, you can also take, 43 and 26. Try to find the difference between them. 43 minus 26 is also 17. So in case you can't see what the difference is, the difference here is actually plus 17, making our common difference plus 17 and n minus 1. So that's our function rule. Now if we want to find the 100th term, what we're going to do is just plug 100 in for n. So -8 plus 17 times 100 minus 1, which is, of course, 99, right? So when we calculate this, we're going to do 17 times 99. 17 times 99. And then add -8 to it, or just do -8 plus that number. So -8 plus 1683. 1683, by the way, is the result of 17 minus 99, which gets us 1675 as a final answer. 1675. Okay. So that one is more or less problems we've practiced a lot. So hopefully we can manage to do that. Just remember, you have to write a formula and then use your formula. So number 6, find an explicit rule for the sequence. So an explicit rule, so this is kind of like the same thing we just did in number 5, except we're not actually going to plug a number in at this point. We're just going to write the explicit rule. So same formula, f of n equals f of 1 plus d n minus 1, right? And just plug in our two values, right? So it'll be f of n equals f of 1, which is our first term, -3. So -3 is our first term, plus our common difference. Now our common difference here, you might be able to tell, is 6. So adding 6, n minus 1. Again, another heads up, just as I mentioned before, I just looked down at the test, and once again, the answer choices were not written in this form. So let's simplify this real fast, okay? Oh, by the way, I'm starting to think I might just rewrite the answer choices on the test so that they are in this form, but we'll see. But if they're not, here's what you do. So if you want to simplify, -3 plus 6 times n minus 1, right? If you want to simplify it to a different version of it, you can just distribute the 6. So that'd be 6n minus 6. And then you can combine these two. -3 minus 6 is -9. All right, plus 6n. Just bring down the 6n. So this would probably be how it would look on the test. But again, I might change it. So I'll figure that out. But there you go. Just keep something like that in the back of your head. All right, find the explicit rule for the sequence. So, yeah, this is going to be very similar again, so keep that in mind. Now, the first thing I want to do is actually find what the sequence is. So, our sequence, and then I'll write the explicit rule. Our sequence starts with the number 13, and then, remember, this is recursive, so this f of n minus 1 crossing it out, putting a little space here. Now you're going to be confused at first because what you're going to notice is it's just a space. Literally the entire thing was f of n minus 1. It's not squared. There's no number times it. There's no number adding to it. F of n minus 1 completely disappears, and that leaves absolutely nothing on that side. But that's okay, right? So when we plug in 13, right, the result remains 13. It's really, there's nothing that changes to it because you're not adding anything to it. You're not subtracting anything to it. You're not multiplying. You're not doing nothing. So the second term will also be 13. And guess what? When you plug 13 back in, oh snap, it does the same thing, right? Nothing changes because it's not adding anything, not subtracting anything. So every term here is actually 13. The reason for that, just to explain what this really means, it means that the current term equals the previous term. It means that every term after the other is equal to the term right before it. And so if the first term is 13, then every term after 13 is going to equal 13. So our sequence is literally just 13, 13, 13, 13, 13, which is fine because that makes our common difference just plus 0. We're adding 0 every time. And there's nothing wrong with it. It's just a little uncommon. You don't really see that a whole lot. So if we're going to write an explicit rule would be f of n equals f of 1 plus d n minus 1. Now in this case, when we plug in our f of 1 and our d, so it'll be f of n equal to f of 1, which is 13, of course, plus 0 times n minus 1. And even if you distribute the 0 times n, 0 times negative 1, 0 times n minus 1 in general, this whole thing, because being multiplied with 0, is just 0. So it's essentially kind of pointless, right? It's the same thing as saying 13 plus 0. F of n equals 13 plus 0, which means f of n just equals 13. That is the entire function. Looks a little bit odd, definitely very unique. But it is something to just keep in mind. It's weird, it's weird and uncommon, but it's still possibility. All right, number 8. Write a rule for the nth term of the sequence. What time is it, by the way? Okay, we're good. All right, write a rule for the nth term of the sequence. So, and then use it to find the 100th term. Okay, so let's write a rule. F of n equals f of 1 plus d n minus 1. Again, this formula shows up all the time, so make sure you use it. We're going to use that formula here. We're going to plug in what we need. All right, so this is going to be negative 8 as our first term, plus 8, because you'll notice our common difference is adding 8, and minus 1. So now to solve for the 100th term, we're just going to plug 100 in for our n and evaluate. So that's going to be 8 times 99. 100 minus 1 is obviously 99, so 8 times 99. And then negative 8 plus that. So negative 8 plus 792 is 784. So 784 would be the answer here. So remember, use your formula, plug in the two values that you already know from the sequence, and then plug in, of course, 100. And the next problem, we're going to do the same thing, but we're going to plug in 30. So rather than rewriting this rule again, I'm just going to use it as a template. So f of n equals, we're going to have a first term, which is negative 4, plus our common difference. Now our common difference, it might be kind of tricky to tell, but we are adding 9 every time, so plus 9 and minus 1. That's our formula, and we're looking for the 30th term, so we're going to plug 30 in for n. So when I solve this, I'm going to do 9 times 29, 9 times 29, because remember, 30 minus 1 is 29. 9 times 29 is 261, so negative 4 plus 261 is 257. So 257 is our answer for this. Do the exact same thing again in number 10. So f of n equals our first term, which is negative 10, plus our common difference. Our common difference here is adding 2. As the negative numbers get smaller, that means we're adding numbers to it. So it is plus 2 and minus 1. You could be forgiven for thinking that it might be minus 2, but it's not. All right, but again, we're looking for the 70th term, so we're going to plug 70 in for n. So that's going to be 70 minus 1 in there. So 70 minus 1 is going to be 69, so we're going to do 2 times 69, which is 138, and then negative 10 plus that 138 is 128. So 128, our answer. Write a recursive rule for the sequence. Okay, so To write a recursive rule for this sequence, we're going to need two things. We're going to need to know the first term, right? F of 1, which is just -6, pretty straightforward. And then we're going to write our formula. So our formula is very similar. Remember, we did this back up in number, what number did we do it? The very first problem, number 1. Okay, so it's very similar to number 1. So the formula you're following is f of n equals f of n minus 1, and then plus your common difference. So literally all of this is going to be the same. All you're going to need to change is this d value at the end of your common difference. So in this sequence, we are adding 7 every time. So it's going to be f of n equals f of n minus 1 plus 7. There's your formula. So if you memorize this, right, you're going to be really set for tomorrow's test because it's going to be the same thing on tomorrow's test. Same formula, f of n equals f of n minus 1 plus 7. This will always stay the same no matter what. When you're writing a recursive rule for an arithmetic sequence, at least, just keep in mind the only thing that you're going to have to change is this number, and that depends on the common difference, right? Obviously, ours was plus 7 since we were adding 7 for each part of the sequence. So number 12 and 13, write an explicit rule. Or it doesn't write, it says on the test write an explicit rule, but this one says write a rule for the nth term. But of course, we're going to write an explicit rule. So f of n equals, remember, explicit rule is the formula from up there, but I'll go ahead and write it down one more time. F of 1 plus d times n minus 1. So when we plug in what we need, f of 1 is going to be -12, and then our common difference is adding 7, plus 7. It's kind of tricky to see with all these negatives, but we are adding 7 there. And that's it. That is our function. We're already done, right? So with the formula, it's pretty easy because you just plug in those numbers. And then lastly, f of n equals f of 1 plus d n minus 1. We're doing the same thing in number 13 as we did in number 14. Just going to plug in some numbers. So f of 1 means our first term, which is 16. That's given to us there. And then d, our common difference, is the fact that we're adding 3. It's plus 3 in the sequence. So plus 3 is your common difference. And there is your rule. Just like that, this is over. And that is the test. So I think things to be mindful of are memorizing the two formulas. It's very, just a quick summary before you turn the video off. A quick summary, f of n equals f of 1 plus d times n minus 1. You're going to use this formula every time it asks you for a specific term. If it ever asks for f of 70, f of 100, whatever it is, the 70th term, the 100th term, the 9th term, whatever it is, use this formula, right? When you're making a rule, when it says write a rule, if it doesn't say write a recursive rule, write this one, okay? And just change those two numbers. The other one to keep in mind is the recursive one, which is f of n equals f of n minus 1 plus d. This one used a little less often, but sometimes it asks for it, like it did in number 11 and like it did in number 1. Number 11 and number 1, it asks for the recursive rule, so just be mindful. It's a very simple formula. You're always going to keep f of n minus 1. That part of the formula will never change. The only part that will change is the number you add here at the end. So keep that in mind. Don't do anything different here. Okay, your recursive rule always starts this way: f of n equals f of n minus 1, and then plus whatever the common difference is. So this, the only thing you're going to have to change. All right, that was just a quick recap. Keep those things in mind, and good luck on tomorrow's tests.